Okay, so if anybody's interested in looking up here for number 4, remember we talked about if an equation, if a graph is reflected about the y-axis, so here's y, here's x. If it's reflected about the y-axis, the original x in xy becomes, for the new function, becomes negative xy, right? So the x values are flipped around. Now with the parabola, because they're symmetrical, the reflection may map right onto itself. And this is the case, but how would you know that? Well, wherever you see a positive x, you replace it with negative x and then simplify the expression. So h of x, which would be your reflected parabola, would be like this. Wherever you see a positive x, you put in a negative x. And when that's simplified, it becomes the exact same. See, h of x and g of x, the original mother function, is exactly the same. And so that's why it maps right on itself. Okay? So that's 4a, and in order to get the equation of the reflected function, you either replace x with negative x, or you replace y with negative y if you want to show the equation that would be reflected down here, which I will show you that too. So let's say that let's do k. K of x, another function here that would be reflected about the x-axis, would be where this is negative, right? So we have x squared plus 1. So h of x then is actually the negative version of all this. There's your equation now for the reflected parabola in the x-axis. The whole side, x squared plus 1, is all multiplied by negative 1. And this negative is not inside with the x, of course, it's separate like that. And we could confirm that by graphing, which I'll do in a second. If I graph both of these functions, just to double check, here's the original function, and here's the one that should be reflected about the x-axis, and I graph that, and sure enough, here's your original function, and here is the other one, and they're reflected, okay?